Hello, everyone, and thank you so much for joining us for another live FasTech seminar brought to you by MFC Group. My name is Robin Mangold, and I'll be your moderator for the session today. Today's session's title is What's Not Hot in Power Semiconductors, Innovative Packaging and Thermal Management Methods. And just a few housekeeping items before I hand it off to the first presentation. Everyone is muted, so please feel free to type any questions you may have into the chat for this Teams meeting. Amanda will be monitoring the chat for your questions, and we'll work with the presenters to provide answers during the Q&A. We are recording the seminar, and I'll send out a link to the recording and the slide deck to everyone attending in the next few days. And please stick around to the end of the presentation and participate in the trivia contest for a chance to win some of these cool prizes. Now, let me tell you a little bit about our first presenter. Today's presenter from Littelfuse is Chad Collerat. Chad is the Business Development Management for Littelfuse Semiconductor Division, covering the Midwest for the last 8 years. He has had another 13 plus years of experience in the semiconductor industry since graduating from Marquette University in electrical engineering. Chad, welcome, and I'll hand it off to you.
Thank you, Robin. Appreciate that. Hello, everyone. Thank you for joining us. I am going to cover one of the focus products for Littelfuse IXYS today called SMPD. It's a relatively straightforward surface mount power device. Within Littelfuse itself, go ahead and advance, Robin. Within Littelfuse itself, we tend to focus heavily on packaging in addition to not only the silicon. And the reason is because everyone fights with the standard list of issues as far as thermal and also stray inductance and other issues that come into designing the power stage in an overall design. On this particular page is just a preview of many of the different package options we offer that are typically focused on the industrial marketplace. It could be also in a lot of other industries as well. But for today's discussion, I'm going to primarily focus on the bottom two in the center, SMPD. The big advantage of these particular packages that you're seeing on your screen at the moment, you have isolated and non-isolated solutions, both some that are overmolded plastic, some are electrically isolated through ceramic backsides. Anything that says ISO in the naming of it has the ceramic backside to it, and that allows you a lot of flexibility in your approach to your design, mainly because you can create a quasi-module approach to deal with some of the many issues you have as an engineer, such as putting different topologies in a single package. There's a lot of advantages to that, which, mainly as far as lower inductance in your overall design, but the capability to mix different silicon technologies in a single package too to create what you need from a solution standpoint. Robin, you want to? Yeah. Within Littelfuse itself, too, we're not only limited to just the discrete packaging, but we do up to the module level solutions as well. I don't want to omit that from an offering standpoint, but if the need be, it's all based on the power level you're designing with today. But for today, we're going to focus on mainly SMPD. Next slide, please. There you go. The SMPD package as it is today, we currently offer two main lead frame options. The packages are exactly the same. So the top side is your thermal path, where the die are actually soldered to the bottom side of that. It is a ceramic isolation material. The housing itself is a standard plastic overmolded type package with a lead frame that allows different topologies to be used internally. The one on the left, like it says, single switches or co-pack, it's with an IGBT and diode across, our typical single device. And then the one on the right would be your other topologies, phase legs, or it could be rectifiers, or it could be, whatever it may be, boost, buck. All those types of different topologies are offered with this particular package. The size itself is rather large to a lot of discrete solutions that are on the marketplace today, but it does give you something that many of them do not offer, which is more usable power out of the same physical size. And why is that? Is because the lead frame itself is significantly heavier thickness of metal on the lead itself. So the current rating on a particular pin is going to far exceed the typical TO247, TO220 type packages that are on the marketplace today. But again, there is a place for everything. So depending on the power level you're dealing with, or if you're trying to put everything in the one package, we do have alternative other lead frames available in production today. These are just two of the standard ones that the mass market product offering we give today is available in. Next page, please. To give you kind of a physical view of what the SMPD is built up and how it actually addresses the actual overall issue of thermal management. This gives you a viewpoint as to what I'm referring to. With the package being large and people wondering, how do I mount it? How do I deal with, with the different issues that go with the mechanical nature of it? This at least gives you the thermal stack up from a visual point of view. Like I mentioned before, isolated packaging, so you have copper, ceramic, copper stack up with the die bonded to the bottom side of the top. And then it's, obviously the package is surface mountable. That also deals with a lot of the issues that people have in higher power density applications is like, man, all these through-hole parts, what a headache, because you have to deal with paralleling parts possibly in certain power ranges, or you're just dealing with, if you're doing, an interleave design where you have a lot of diodes and a lot of IGBTs and anti-parallel diodes being used all in one particular design, it tends to get very ugly very quickly. So this package was created to try and bridge the gap between your standard discrete packages that are through hole for the most part, and put it onto a surface mountable package that the contract manufacturing teams are going to enjoy dealing with a lot more so than maybe through hole where you have mixed boards. So anyways, next slide. Also too, the package itself from us is not exclusive to one silicon technology all on its own. We offer it in standard silicon carbide, IGBTs, and all the bipolar technologies, diodes, thyristors. Within Littelfuse itself, we offer all these silicon technologies internal to the company. This is just a path to allow you to do greater power densities, maybe higher voltage, maybe lower voltage. It's really just a platform approach in dealing with the overall power section design of a particular project. Next page, please. So here's just a visual of a typical smaller module design layout. Some of the, like I had mentioned early on, some of the issues you deal with from a design standpoint is mounting, inductance over the overall path, the assembly of the actual product, selective soldering can sometimes be an issue, and then sometimes snubbering over a particular design. Next page, please. What the SMPD allows you to do, not only to deal with some of the thermal challenges that go with that, but is to split up the design possibly so that you can better manage that heat. Like the other team members we have with us today are going to talk about, you can use this part as a surface mount device and put it anywhere that's more convenient to you relative to maybe your DC bus link caps, for a motor drive design, or, for your active front end, maybe put it closer to your AC input versus the actual inverter maybe being further spread apart on the PCB somewhere else. There's lots of different approaches you can take. And what this allows you to do is just to maximize your board area, or possibly allow you to use a more standardized PCB material versus a specialized metal clad board or something else more extreme in the higher power ranges that you might be forced to. Again, these are just standard examples here, but you're not really limited in what you possibly can do. Go ahead and next slide here too. I did another example here of an actual design we assisted with. On the left is a standard power design. It kind of shows you the flow from the AC to DC side through the two phase leg through hole type design. And the one on the right is an SMPD solution with the same phase leg design, but the amount of distance from A to B, basically gives you kind of a visual point of what you might have to deal with from your perspective in implementing the same circuit. Shorter power loops are always going to be better, especially when it comes to inductance or the gate rain, which can be a serious issue, especially if you're dealing with higher frequency type designs with carbide and or MOSFETs. So just, it's obviously oversimplified for everyone on the call here, but again, it's just something to think about from an implementation standpoint. Next slide, please. Like I mentioned before, the benefits of SMPD, this is an actual design a customer had done. Moving your different sections and topologies around on your board gives you maximized ability to not only deal with the heat that's generated, but also optimize your layout to what is preferable for you. So being a surface mountable package, obviously the contract manufacturing teams will be much easier to deal with. But from you can utilize the housing possibly that this design is going to be implemented into, or a heat sink itself that could be applied discreetly, or as an overall, the whole entire board could be implemented. Next slide, please. Some of the mounting options for the device itself today range from either a simple clip or clamp approach where you have a single discrete screw and washer being used to put pressure down. We do have a full white paper on the details around that. So far as, there is a point of, not getting the most out of the part if you apply pressure to it. So there's a happy medium as to how much pressure is really needed. This is an example here of what the recommended range is for this type of approach. And the next slide, please, should show you another different version of approach, mounting the parts, screws on each side where you have, to ensure that you don't have bending of the PCB, and then mounting directly to your heat sink. The bending obviously is bad for many, many reasons. So the spacer is probably would be required in this particular solution as well. But again, the amount of force being applied to the device, really in the range of 50 newtons is really all that's necessary in this particular case, with a minimal amount of torque on the screws itself too. Next slide, please. This is just some details around typical suggested spacers and washers that we've used on other previous designs, just to give you a little background material when you do get these slides. But again, to kind of give you a tolerance, what does my tolerance stack up? It gives you also some details here around that as well. These are all just suggested. There's plenty of other ways to do this. Next slide, please. Another way, if you have multiple devices being used in a particular design, and what else can I do when you have that scenario? Here might be the full inverter for like a motor drive example, where you'd have 3 devices doing your 3 different phase legs, 1 per phase. Again, there's a counter bracket approach where you evenly distribute the pressure across all 3 devices under the PCB. Again, these are all just ideas from different things that we've done. Obviously working with your heatsink supplier, with your thermal grease or thermal pad supplier is going to implement different perspectives on how to properly mount these. So, please keep that in mind as well, because getting the heat out of the package is obviously one of the most critical parts to maximize the power density for yourself. Next slide, please. Also, to give you some more reference material for later on, this is far as the amount of bend that you want to minimize with the PCB relative to the part. And before you start seeing some other issues start popping up with your soldering and or performance contact to your heatsink. So please be mindful of that. The white paper that we have access to, we definitely can provide, and is on the Littelfuse website too. Next one. Again, it goes back to how much force do I really need? Obviously, the thermal interface material being used is critical to that, along with the heatsink smoothness is also going to be an important part, because I do have customers that do air-cooled versus water-cooled in some applications, so you have to be mindful of that as well. Obviously, each one has its ideal solutions. But again, there is really a point of really optimized is the 50 newtons being the prime example of one that's preferable for maximized thermal transfer. Next slide. Some other examples that we've done with customers too, utilizing the same amount of force, where if you have an encapsulated design, because many power designs are due to the market going EV, you're going to have a lot of applications which are going to be fully encapsulated. So thinking ahead as to how do I use that, or how can I use that to my advantage? This is an example where the actual whole unit is utilized to put pressure down on the part versus maybe some bracketry being done. So basically an all-inclusive case. So just, again, ideas on what other customers have done to try and implement the design and still make it thermally possible to do it all. Next slide. Here's just an example of a demo board. The whole point of this that we had done for the customer base is to show some of the thermal spreaders that we have done. On the bottom there is the clip approach. We in the middle there in the top, you got the multiple device clamp approach. And then on the left, you've got 2 screws on each side of the device approach. So depending on what you have clearance for, what you have ability from an assembly standpoint to do, lots of different approaches to take. But again, this was just an example motor drive design we had done. Next slide. Everything that I've covered today, as far as the devices themselves, are on the website at littelfuse.com. And if you wanted to find all the details all at once, the easiest way to just put SMPD in the search engine up on the top, and that'll bring up pretty much all the different product categories that we offer in this particular package today. And then there's also the link in the bottom there, mounting and cooling solutions for SMPD, that will be accessible through this presentation as well, that you can access. There are continually putting new white papers together on this, and we're doing some other new demo boards too, with motor drive being kind of the first one out. That'll have some more modular approach where you have carrier cards, maybe on a bigger design for a motor drive. Those will be coming out shortly for PCIM in Europe. So keep your eyes open on the website for that, and the Mel Foster team will be sending out updates as they get rolled out as well. Next page. Okay. So in conclusion, SMPD, basically it's a power platform, not specific to one silicon technology, not specific to one topology, but it allows you from a design perspective to optimize your power design, optimize it for the thermal issues that you're dealing with from your design, keeping things like your inductance down in your overall design, along with the capacitive, because depending on how fast you're switching products, your DVDT or DIDT is going to have a significant impact on your final design. So putting silicon as close as possible to each other and then being able to thermally manage it properly is key reasons to take a look at this approach, possibly give you some advantages that maybe you hadn't thought of before. So next slide, please. And thank you. That is the end of my presentation. Are there any initial questions, Robin?
Right now, the one question we've had is just if the recording will be available, and the answer is yes, it will be. We'll be sending that out in the next week. As of right now, Chad, there's no other questions in the chat.
Very good. Well, thank you, everyone, for attending. I'll let my other colleagues take it from here.
All right. Thank you so much, Chad. Our next presenter is Greg Wong, Director of Product Engineering for ATS. Over his 12 years at ATS, Greg has worked on thermal management solutions, applications for a wide range of industries, such as telecom, datacom, consumer electronics, industrial power electronics, automotive, and transportation. Welcome, Greg, and thank you for joining us.
Yeah, thanks, Robin. Yeah, well, could you go to the next slide? So we'll just introduce our company really quickly, and we'll look at some of the products that we offer, both air and liquid cooling. And then we'll look a little bit more in depth at a couple of examples that we'll see are relevant to what Chad was talking about with the SMPD packages. And then we'll talk about the design services that we offer. Next slide, please. Okay, so yeah, you'll have to forgive me. I have a little hoarse voice today, but I think we'll be okay. So our company was founded in 1989 with roots in Bell Labs. And we eventually made our headquarters in Norwood, where we are today, with over 60 direct and contract employees throughout the United States and across the world. So we have many years of experience with thermal management, as well as the mechanical packaging of the electronics, whether that's the spacers and springs that are required to create mounting pressure, or a whole entire chassis that the electronics go into. We work on all of that. And we have design centers around the world, like we mentioned. So I'm not going to talk about all the rest of the points on here because we'll touch on them as we go along in the presentation. Can we see the next slide? So ATS is focused on our customer service, and these are the basic steps that we go through when we interact with customers. First, we find out about the application, and we find out the specifications and anything else that might impact the design of the components. Then we go into our engineering, where we have our team review the requirements and propose solutions. And then we can provide prototypes, we can provide testing services, and then we deliver products that are designed to provide the optimal thermal performance with the most competitive cost. Could we have the next slide, please? This is just an example board that shows some of the various heat sinks that we offer. Going from the top, that blue MaxiFlow heatsink is one of the signature designs that ATS has. And this shows our super grip attachment, which is designed for BGA packages. We offer heat pipes, to spread heat effectively. And then going around just shows some of the other catalog heat sinks we have available, such as fan sinks, board level stamped heat sinks that you might see for transistors and stuff like that. We offer many different extrusion profiles that we'll get into later. And then we have different attachments, such as tape-on heat sinks with that cross-cut heat sink. And then we have push pin attachments. We have thousands of combinations that are available, as well as low profile specialized heat sinks and a line of CPU coolers that are designed for higher powered devices. Robin, please. So again, these are just some examples of air-cooled heat sinks. We have thousands of different heat sinks in different distribution channels. And then on the right side, we see some examples of our higher performance CPU coolers and other, high power, like IGBTs and power electronics, or things that may need heat pipes to distribute the heat and dissipate it somewhere else. Robin, please. Okay. So as I mentioned, one of the signatures of ATS is the MaxiFlow heatsink, where the fins are spread out, but also some of the unique attachments that we offer, such as the Maxi Grip and the Super Grip. So these attachments are designed to clip on directly to BGA packages, so you don't have to put holes in the board, and they provide a secure mechanical attachment for good, optimal thermal performance. We also offer heat sinks with many different thermal adhesive tapes, such as actually in this image, we can see one of the 3M thermal tapes there. And we can also advise and supply thermal epoxies. Some other methods of attachment that we have do require holes in the board, but they may be required for if you have strenuous shock and vibe requirements. So we can offer things such as Z clips. You know, we have a few standard designs, and we can offer custom designs as well. Push pins, as I mentioned, you know, with the different push pins and springs that we offer, we have thousands of combinations to cover different component heights, you know, different mounting pressures, and all kinds of different scenarios. And along with that hardware, we also offer, you know, many heat sinks that go with that. So from the air cooling, we also offer. We're going to go into liquid cooling now. That we have a number of different solutions to cover, you know, different power levels and different size applications. We have high performance cold plates that have lots of surface area inside for maximum heat transfer. We have custom cold plates, you know, to suit particular applications, you know, and they could be made out of copper, they could be made out of aluminum. The tubes themselves could be made out of copper, stainless steel. And then we have tube cold plates, which are also available, you know, off the shelf in our distributors. And then we have other associated devices for the liquid loop, such as the heat exchangers, chillers, and flow meters, and other accessories that you would need to complete the entire cooling loop. Robin, please. Other supporting thermal products that might work along with the heatsink are the heat pipes that we mentioned before. They spread heat very efficiently. You know, we can bring heat from one location where it may be being generated, and we can bring the heat to another location where you may have more room to dissipate it. We offer vapor chambers, which also spread heat in a way similar to heat pipes, but it along a surface, as you can see in this image. TEC refrigeration. These are solid state components where when you apply electrical current, one side gets hot and the other side gets cooled off. So we can use that to control, you know, the temperature of components. And these are all used, like I said, in conjunction with heat sinks or maybe with cold plates, as you can see there. Robin. Oh yeah, Robin, could you advance the slide a little bit more? Yeah. So these are our finned cold plates. So inside we have a very fine fin pattern, and this maximizes the heat transfer. But we've also optimized the geometries to keep the pressure drop low. The performance that we get from this approach, you know, like I said, it minimizes the thermal resistance, and we have extremely competitive thermal performance compared to, you know, other products that are in the industry. Our assembly techniques for these cold plates is unique. It's not a brazed process. It's not a welding process. And because of this assembly type that we have, it enables us to make custom sized cold plates very easily. You know, in as little as 2 to 4 weeks, which you know, and then the minimum order quantity is reduced because we don't have to create tooling and jigs to you know, to weld up parts or to braze them. We offer DIY versions of the cold plate which don't have any mounting holes in them. Oh, I should say that the standard cold plates do have mounting patterns for standard IGBT sizes, but the DIY line doesn't come with any mounting holes, and these are available in our distributors. So a customer could purchase one and then machine it in-house to have the mounting points that they require. So in a matter of days, they can have prototypes to be able to run and test. And then when the customer is looking for, you know, higher volume, if they want to be able to buy these cold plates with their hole patterns pre-drilled, then we'd be happy to provide quotes for that kind of services. Robin, please. So our tube cold plates, so as opposed to the what we saw previously, which the heat transfer is handled by very fine fins, the water instead flows through tubes in these cold plates. This is a more cost-effective approach that for applications where you don't need that ultimate thermal performance, maybe slightly lower thermal performance is all that you need. The tubes are compatible with all the industry standard coolants. The stainless steel tubes do allow for use of more corrosive coolants, such as DI water, which could be a problem potentially for copper tubes. And if our customers have some other liquid that they want to run through it, the stainless steel, it can often be a good option in cases of corrosive liquids. These cold plates do come with fittings that allow it, push to connect fittings that allow the connection of tubes, and we can also advise on other fittings, or we can customize these as well to have soldered fittings on them that would allow like NPT fittings or stuff like that. Robin, please. So a large part of our selection is aluminum extrusions. A lot of our standard heat sinks are made from aluminum extrusions, and we offer standard unfinished extrusions from our distribution as well. And so we offer some of the widest selection of extrusions. And this is often one of the most efficient and cheapest way to manufacture heat sinks. Because we have so many different extrusions tooled up, then we don't require NRE for heat sinks made from these extrusions. And we also can make these without an MOQ. So if we just need to produce one prototype or 5 prototypes, we can leverage these existing extrusions and machine them to fit the customer applications. So our standard lengths for these raw extrusions are 300 millimeters and 1220 millimeters, which is approximately 4 feet. So our customers, have that flexibility to, if they're going to machine the heat sinks themselves, they can buy the long extrusions and, save a little bit of money. Yeah, thank you. So ATS, with our wide product range that we have now, ATS is, at its core an engineering company, and our design process can be defined by 3 basic parts. So first, when we get a problem, we go into analytical modeling. So this is like pencil and paper calculations or Excel spreadsheets. We've also developed a number of in-house calculation tools, and these allow us to get a basic understanding of the problem, develop feasibility studies and stuff like that. And then from there, we can go into computational modeling, where we can set up, a customer could provide a model, or we can generate a model, and then we can simulate the performance, in CFD. And this allows us to get, maybe more detail than we could get through the analytical modeling. And then thirdly, we can manufacture prototypes and test it in one of our thermal labs, either in Norwood, and we have thermal lab that's coming online in India as well, where we can do we can test liquid cooled solutions and airflow air cooled solutions, and we can do all kinds of other measurements like measure air speed and air temperature, as well as pressure drop and component temperatures. And all of these 3 solutions combine, to validate each other. So we understand how the problem is working, and then we know we're going to be able to deliver a product that works. Robin, please. So to look a little bit more in depth at some of the solutions we offer, this heatsink was made for 5G, telecom application, where our customer liked the spring clips that that we offer, that super grip and Maxi Grip that we mentioned before, but the customer needed more force, so we came up with a custom spring, as well as the custom heatsink, and then the spring was designed specifically to match the component height and the tolerances that the customer is dealing with, as well as provide the necessary mounting force. So the spring is tooled up, and it's made out of stainless steel spring material, and we produced prototypes, and the customer tested it out and approved it, and then we moved into high volume production. And the heatsink here is a custom aluminum extrusion. Robin, please. So our second example, this really does get into some of the things that Chad was mentioning, where we had a customer in the transportation industry, where they had accelerometers that they needed that were in a very hot environment, and they needed to tightly control the temperatures of these accelerometers. So we used TEC, the thermoelectric modules, so that we could control and maintain the temperature of that component. And the challenges we had here were the tolerances and how we would apply the pressures to these components and how we would mount them, because the TEC requires very specific pressure ranges to get the best heat transfer. So in this case, we decided to build the mounting spacers directly into the heatsink, which allowed us to maintain very tight tolerances between the heatsink surface and the mounting surfaces. And then we also selected gap pads with the right thickness and the right compliance, so that we could get exactly the mounting force that we wanted to in this assembly. Robin? So this is kind of encompasses a summary of ATS, that we offer the cooling solutions, both air and liquid cooling, for components that dissipate just a couple of watts to components that might dissipate thousands of watts. Right, the design services, as I mentioned, are a key part of ATS's core. Just understanding the theory and everything. We have many PhDs on staff who have gone to school just for thermal management. We also offer training programs to share some of that knowledge that we have. We have webinars, online courses, and we have a Qpedia e-magazine, which is dedicated to topics in thermal management. And then we have a line of thermal instruments to support the work that we do in the lab, so we can measure things like airspeed and air temperature. And we also offer wind tunnels as part of that as well, so customers can test their devices in controlled environments. So that's it, and thank you for spending your time and listening to us.
Thank you, Greg. We do have a couple of questions. So first question, is there a recommended ATS part number for the IXYS SMPD package?
Yeah, at this time there is not, but we'd definitely be willing to work with anyone, and it's possible that we could come up with solutions that could become reference designs and stuff like that.
Okay. Our next question is, do the MaxiFlow heat sinks come with TIM attached?
Yeah, I mean, we're flexible. Some of them do and some of them don't. Most of them do, whether that's a thermal tape, a thermal attachment tape, or a phase change material that would require a separate mechanical attachment. Most of them do, but there are customers who maybe they want to use thermal epoxy to apply them, and in that case we can supply our heat sinks with no TIM.
Okay. Next one is, do you have catalog vapor chamber parts, or are these custom?
Yeah, in general they are custom, but we do have a few part numbers for the vapor chambers that are standard, and we can incorporate into a custom heatsink. Or yeah.
Okay. And last question is, what is the widest profile on the aluminum extrusions?
The widest profile that we're offering, I believe, is about 350 millimeters. But we do have capabilities of extruding, say, like 200 millimeters and then welding sections together to make a heatsink that is as wide as necessary.
Okay. Great. Thank you for answering those.
Sure.
All right, thank you, Greg. Our final presenter is from 3M. Joe Petrie is a member of the 3M Electronic Assembly Solution team and focuses on EMI and thermal design challenges. Joe helps customers gain a greater understanding of 3M product solutions. And for 30 years, Joe has used his experience and contacts to help bring together resources to turn ideas into tomorrow's new technology. Thank you for being with us today, Joe.
Thanks, Robin. I appreciate you being the invitation and spending time with everybody here today. As you can see, this is my contact information. I wanted to share that with you. If there are any questions after our discussion here today, feel free to reach out to me or directly or through your Mel Foster representatives. The Electronic Materials Solutions division is actually part of the overall 3M Transportation and Electronics Business Group. We bring customers' ideas and help them enable their new next generation of technology, whether that will be some of the engineered tapes that I'm going to discuss here today for thermal management. It could also be semiconductor packaging or transport materials for electronic board assembly, as well as our interconnect business for signal management and high-speed communications. But here in the Electronic Materials Solutions division, next slide, please, I focus on these types of assemblies. Folks are worried and work on electromagnetic interference. So we have a range of tape and product solutions that deal with EMI issues. There are thermal interface materials, which we're going to go into greater detail here in just a moment, comprised of 4 different product types. There are high temperature masking tapes that are widely used here with electronic assembly due to the nature of electrostatic dissipating coating that we put into our tapes that help make assemblies more reliable and over time. There's other tapes within our portfolio that are very low outgassing for aerospace and military applications, bonding films that help hold assemblies together with structural strength, and even our new UL50 electronic enclosure iso-loss polyurethane foams. Electronic assemblies are worried about sealing, damping, vibration control, and iso-loss polyurethane foams help deliver those types of solutions to our customers. But focusing on thermal interface materials, next slide. Recent study here was 55% of all electronic failures were due to some sort of thermal and temperature related issues. As such, we have 4 different types of products that we offer the market. Next slide, please. That help enable next generation technology. The first one, and Greg made a quick mention to of it, is our thermally conductive tapes. These tapes are different from a traditional gap pad in that they provide adhesion, high levels of adhesion, bonding and joining a heat sink to the heat source without the use of clips or fasteners. The second product line are, in fact, gap filling interface pads. These thermal gap pads, we manufacture them with 2 different types of chemistries, silicone and acrylic, that offer some very unique features that are relevant for our transportation customers and electronics customers. There's also some thermally conductive greases in our portfolio, typically repackaged into small 5 to 10 gram syringes, which are ideal for wetting out with thin bond lines and offering very low thermal resistance in a thermal grease that's easy to apply. And then there's our thermal epoxies. And these thermal epoxies, once you put these assemblies together, they tend to stay together. And just real briefly, I was going to turn on my camera just for a second and do a simple little demo here to really explain the difference between a thermal gap pad and a thermal tape. Many of you might be familiar with 3M's VHB, very high bond tape. What this tape does is it has a property called viscoelasticity. And what I'm trying to do is separate these two tabs. And what's happening is the VHB has a very good viscoelasticity, which means it stretches and comes back. As a result, it has very good coefficient of thermal expansion issues when dealing with substrates that might be expanding and contracting at different rates. So our thermal tapes that we manufacture are based on that same technology. The first tape I wanted to show you is called 3M's 8810 thermally conductive tape. And why this is different from a gap pad is that, number one, very good wet out on irregular surfaces that could be found on a heat sink, but also very good adhesion. These thermal tapes do not require clips or fasteners to hold a heat sink into the assembly. If we tried to do this same demo with this golf ball, which is very difficult to stick to with one of our thermal gap pads, yes, gap pads can wet out very nicely, and I'll talk about that in a moment, but they have no adhesion. They will require a fastener of some kind to hold that assembly together. So going back to my slide deck here, I'm going to focus on the tapes now. One of the leading ones that we have here is a product called 8810. And if you turn the slides back on for me there we go. 8810 has this coefficient of thermal expansion. It can really help with the bond line to protect the bond line over the life of the particular assembly. 8810 comes in various thicknesses. Our thinner versions, like 8805 there on the screen, is down to only 5 mils thin, but still offering that high degree of adhesion. There's some other tapes that we have, which are now becoming more popular as the power of some LEDs are increasing related to the agricultural market. But our 8926 thermal tape has that same degree of high adhesion, but it also offers 1.5 watts per meter Kelvin of thermal conductivity, which is quite high in a thermal tape. Applications for our product on the next slide would be, for example, like I just mentioned, the agricultural market. These LEDs are burning bright, and you can ensure a long product life and overall quality by using thermal tapes that help dissipate that heat and move the heat from the back of that LED board to the frame, which is quite often working as the heat sink itself. Other applications are in the automotive space. Go to the next slide, please. Here's an example of a high-powered LED using for either headlights or taillights. And inside that assembly, they're looking for shock vibration damping along with high adhesion. And therefore, they rely on these 3M thermal tapes, such as 8810, to provide that bond strength and thermal conductivity. So the next product category I'll touch on briefly is our thermally conductive interface gap pads. Greg talked about a lot of his clips and fasteners that will have a gap pad interface between the heat source and his heat sink. And if you notice, we have not only silicone gap pads, which are found across the bottom of the chart, but also acrylic gap pads. Why this is important is that over time, the siloxane outgassing that can occur related to silicone chemistry can be negated completely by the use of our acrylic chemistry. So products such as 5550 up on the upper left corner has got 3 watts per meter Kelvin, ULV0, but a Shore value of only 30. This makes it a very compressible and conformable gap pad, similar to a insole in your shoe. You'll get very good wet out and improved thermal conductivity by the use of some of our softer pads like 5550H. We have some other pads even down at the bottom. I'm going to just mention it's on the lower left corner. That's got a Shore value of only 15. It literally is like a gummy bear. It is so soft and the topography of what you're trying to cover may warrant a gap pad with that level of compressibility and softness. Next slide, please. Lots of applications for our thermal gap pads, as you just saw in all the heat sinks and in electronics in general, but a very large market also is keeping these rolling computers, electric vehicles cool. Often you'll find our acrylic gap pads used in conjunction with a cold plate. And the reason why they lean toward the acrylic chemistry is that acrylic chemistry is about 25% lower in weight than the equivalent size and thickness of a silicone gap pad. In the automotive EV marketplace, light weighting is everything, and that makes the acrylic chemistry very attractive for a market like electric vehicle. The third product category that we have would be our thermally conductive epoxies. So again, these are two-part systems that are pre-packaged in 50 milliliter containers. We call those duo packs. They're also in 400 milliliter for higher volume, robotically applied, thermally conductive epoxy applications. And there's even some 5 gallon pails that can be dispensed in large volumes robotically, depending on the given application. Our core thermally conductive epoxies are TC2707, which is comprised of aluminum fillers. But what's very interesting for a lot of the electronic assemblies is our boron nitride ceramic filler found in TC2810. So these applications requiring electrical insulation lean toward that TC2810. Applications where there might be just wanting good thermal conductivity with a copper tube or liquid cooling setup, they would lean toward TC2707. So heat sink attachment, potting, good applications for thermally conductive epoxies from 3M. Next slide, please. One of the interesting things about these tapes that we do, though, is working with converter partners and our distribution channels to reduce overall cycle times. If you have high volume applications where you're looking for speed to assembly, I wanted to share with you pictures on the left here of small peel tabs that we incorporate into our thermal tapes that allow for more accurate placement or the ease of which to assemble and remove the liners to expose the adhesive prior to final assembly. So if there is a desire in a high volume application for speed and cycle time reduction, please work with your Mel Foster sales representative and myself, and we will connect you with our converter partners who can talk to you about the best way to go about having that manufactured. Our other channels, though, good friends at DigiKey and Mauser, they stock many of these thermal gap pads and thermal tapes in some already pre-cut sizes and packages. So if you have a particular size and configuration that you're trying to source, look to our electronic distributors, partners, and see what kind of inventory they have that could supply you materials very quickly and very, very fast. Don't forget, volume buy discounts are available from our electronic distributors as well. Hey, the last slide is really just to say thank you for the time here together today. You know, we've got a wide range of different products that are really help enable next generation technologies, your ideas, and we help them come to fruition. So whether here in the thermal management space or in other electronic assemblies, we look forward to working with you on your next design challenge. Thanks, Robin.
Thank you so much, Joe. At this time, we don't have any questions, but we do have some time. So if you have any questions, please put those in the chat. But want to thank everyone, all our presenters and participants for taking the time out today. I will be sending out the recording and the slide deck to everyone in the next few days. If you have any questions or would like information about this topic, please do reach out to me or your field representative. I hope everybody has a wonderful day. Thank you again.